The two Voyager space probes, humanity's longest-serving outposts, have penetrated a cosmic region that previous explorers would have even dared to imagine. Even though these unmanned spacecraft left our planet more than 45 years ago, they are far from finished with their mission. In contrast, the probes are still sending valuable data from interstellar space, demonstrating once more that numerous cosmic secrets remain undiscovered. Are you curious about the remarkable observations that Voyager has made at the outer edge of our home system? Then stay tuned and watch the video today all the way through. Make sure to sign up for Simply Space if you want to keep up with the latest discoveries and mind-blowing spectacles in the universe. To join us on our journey to the universe's greatest mysteries, click the bell. If you give us a thumbs up, you'll inspire us to keep you interested in our content. The Voyager's astronomical success story is truly remarkable. Despite the fact that the spacecraft are now sending data from faraway interstellar space, their original objectives were quite different. The exploration of the outer planets of our solar system, which had only received sporadic research up until the late 1970s, was the primary focus at first rather than interstellar space. By deciphering their atmospheres, conducting structural and chemical analyses, carrying out geomorphological investigations of their moons, and decoding various magnetic fields, the mission aimed to enhance our understanding of Jupiter, Saturn, Uranus, and Neptune. The identical twin probes set out into space on August 20th and September 5th, 1977. Voyager 2 launched before Voyager 1, and their first mission was to investigate Saturn and Jupiter. Researchers were able to gain a more precise understanding of our distant planet neighbors than ever before thanks to the revealing images they took. Voyager 1 became the first human-made object to travel into interstellar space in 1981. In the meantime, Voyager 2 made intermediate stops at Uranus and Neptune, adding 9 moons to the star charts that were previously unknown. After completing its mission to Neptune in October 1989, Voyager 2 also set course for the solar system's outermost regions and advanced into interstellar space. In 2012, Voyager 1 reached interstellar space, and 6 years later, Voyager 2 did the same. Amazing results have been obtained from this technical escape from the solar system. Space between stars is even stranger than we thought. It is essential to examine the interaction between solar winds and the interstellar medium in order to comprehend these findings. Our Sun is a nuclear furnace that moves through space at an insane 450,000 miles per hour, not an immobile celestial body. Solar winds spread throughout our solar system and eventually come into contact with the interstellar medium thanks to an invisible network of dynamic magnetic field lines around our Sun. Along these lines, electrically charged particles escape. Solar winds and the interstellar medium, made up of gas, dust, electromagnetic radiation, and the galactic magnetic field, do not mix well. Instead, the solar winds create a bubble-shaped bulge in the interstellar medium that shields us from most of the cosmic radiation and extends approximately 11 billion miles. In 2012, Voyager 1's heliopause data demonstrated that this cosmic threshold was significantly different from what scientists had anticipated. It was determined that the pressure that interstellar particles put on the heliosphere must be 10 times higher because the interstellar magnetic field was found to be 2 to 3 times stronger than expected. Researchers focused more closely on Voyager 2's passage 6 years later because the plasma temperature measurement instrument on Voyager 1 had malfunctioned. The plasma surrounding a body becomes denser, slower, and hotter when it gets within 140 million miles of the heliopause, as was documented for the first time in research history. Interestingly, scientists had not anticipated this plasma's much higher temperature, which was measured at over 54,000 degrees Fahrenheit. However, the temperatures in the vicinity of the space probes are significantly lower due to its diffuse and thin nature. Additionally, Voyager 2 provided evidence that plasma crosses different areas from both sides. Voyager 2 encountered a much more dynamic region while Voyager 1 passed through a static area with a rapid deceleration of the solar wind. The heliosphere's mysteries can only be deciphered through subsequent missions. This structure's exact shape is still unknown to us. It is still unknown when the subsequent probes will follow in the footsteps of Voyager 1 and 2. When Voyager 1 abruptly began sending a jumble of telemetry data to Earth last year, researchers encountered an unidentified issue. It appeared at first that the alignment of attitude and control had been tampered with. However, the reliable radio connection and trouble-free information collection indicated that it was fully operational. Although the spacecraft was sending illogical telemetry data, the Attitude Articulation and Control System, ACS, which is in charge of making sure the main antenna always points in the right direction toward Earth, appeared to be working properly. The spacecraft continued to function normally, receiving commands from the ground and transmitting data from its scientific instruments without any problems. The most significant mystery. The fact that the signal strength had not diminished indicates that the primary antenna was still facing Earth. NASA engineers did a lot of research and found that Voyager 1's ACS system was still working right, but the data was being sent through an onboard computer that hadn't been used in years, which was the cause of the distorted signals. Scientists successfully restored correct telemetry data by transmitting a command to use the designated functioning onboard computer. However, the reason Voyager 1 resorted to the faulty onboard computer is still unknown. Another electronic component might have issued an incorrect command. The knowledge that both space probes have backup systems that can be activated in the event that a problem cannot be fixed provides some reassurance, while the experts continue to investigate the cause of the error. When additional flight control thrusters were used to make up for the loss of attitude control thrusters in 2017, one of these backup components was already in use. The two spacecrafts' operational duration is currently unknown, but NASA officials hope to extend their mission as long as possible. The last Voyager experiments are expected to be shut down around 2025, but radio contact may continue until the middle of the 2030s if nothing unexpected happens. The spacecraft will continue their journey even after their scientific mission is completed. At a distance of 1.6 light-years, 17 light-years away from us, Voyager 1 will pass the star GLE 445 in about 40,000 years. The probe will have traversed a distance that is equivalent to circling the center of our galaxy in 225 million years, which is a long time after humanity may have perished.